Hello, today we are going to look at the average value of functions. And this formula is not in the log tables, we need to know it by heart. So the average y output, so the average value of f of x, the y output of our function on the interval a to b, so this is again a way of writing range from a to b. The average f, which I will often write as f average or FAVG, is equal to the 1 all over the interval effectively from b to a, so the difference between our highest and lowest value of our interval, multiplied by the integral from a to b of our function. Now, that formula looks a little bit different than what we're used to, but it does have a link to something that we already know quite well, and that's velocity time graphs. So if we think about our velocity time graphs, one of the key facts about velocity time graphs that we would have known for a long time is that the area underneath the curve, the area underneath the function line when we would have had a velocity time graph, was equal to the distance traveled. So what we would have done when we were dealing with velocity time graphs back in junior cycle and a little bit in Leaving Cert is the average velocity for a journey would be the total distance divided by the total time of the journey, which would have been the area under the curve divided by the change in time, or the total time. And that's essentially what we've got here. If we imagine that we were getting the average velocity, as we're going to in a question over here, if we were getting the average velocity, we'd get the area underneath the velocity curve and divide it by the interval, divided by the change in time, or the total time for our journey. So this formula links back to something you already know quite well in terms of velocity time graphs. But let's put it into practice now. Let's use the formula and just see what it looks like when we use it. So find the average value of f of x is equal to this on the interval 0 to 3. So all we're looking for then is the average y value of this function from x is 0 to x is 3. So let's sub into our formula. F average is going to write down your formula, because again, this is not in the log tables. It's very important we take every opportunity to get it well ingrained in our minds. Well, our interval is 0 to 3, and this is our f of x. So this is going to be from 3 minus 0, the integral from 0 to 3 of 3x squared plus 1 dx. So that's what we need to get. And this is a normal definite integral. So we just have 3 minus 0 is 3. Get our integral, increase the power by 1 and divide by the new power. Plus increase the power by 1 and divide by the new power from 0 to 3. So we end up with a third. 3 divided by 3 is 1, x cubed plus x from 0 to 3 is equal to, third should be still out here, on 3 cubed plus 3 minus 0 cubed even, plus 0. And that gives us a third on 27 plus 3 is 30 is equal to 10. So that is our average value for our function on the interval from 0 to 3. So this, again, it would be an average y output for our function on the interval from x is 0 to x is 3. Now, let's put this into practice with a slightly more wordy type question that might look a little bit more like something we get in an exam most of the time. You can get something that straightforward, but let's have a look at this. A car starts from rest drives east along a straight road and then stops. Its velocity in meters per second is this. Find the car's average velocity during the drive. So we're given some information in a story format, and we're going to need to translate it into maths. We're told that the car starts from rest and then carries on in a particular direction and then stops. So it doesn't go back the other way. It doesn't change direction. It just keeps moving east in a straight line and then stops. So if we think about what this function is going to do, this is a negative quadratic, so it's going to be a frowny face type function. We know that it is going to start from rest. It's going to continue on in a particular direction, so its velocity is going to keep being positive, and then at a certain point it's going to stop again. So what can we interpret from the English of that question? Well, we're looking for the roots of this function, and we're interested in the interval when it's traveling in a particular direction from from rest up to when it stops traveling in that direction. So that's what we're after. So we have v is equal to 6t minus t squared, and we want to find its roots so that we know from where it's starting from rest to where it is again at rest, where it's not moving again. So solving that, I always look for my common factor first, and I can see I have a common factor of t. So I can take out that common factor of t. So therefore, or t is equal to 0 would be a valid solution to that, or 6 minus t equals 0 would be a valid solution. So t would be equal to 6, and we're dealing in seconds. Here we have meters per second, so our time is going to be in seconds. So this now gives us the interval for our journey. It's from time is 0 up to time is 6 seconds. And we are able to then get our average value. So our average velocity is going to be b minus a. The integral from a to b of b and t dt. Subbing into that, we have 1 all over 6 minus 0, the integral from 0 to 6 of 6t minus t squared dt. And we know how to get that integral here. So we are going to have a sixth on 6t squared all over 2 minus t cubed all over 3 on the integral from 0 to 6 to a sixth on, oh no, sorry, I need to simplify that first. So don't try and sub into that while it's still a mess. We have a little bit of tidying up that we can do there. 3t squared, so 6 into 2, t cubed all over 3, 0 to 6, we'll do a sixth on, first the higher number goes first, 3 on 6 to be squared minus 6 cubed all over 3 minus 3 on 0 squared, 0 cubed all over 3. Very important that you always write this in, both for a consistency of showing what you're doing, and also because if you get in the habit of assuming that this is just going to be 0, when you come to trigonometric or exponential integrals, you will almost certainly make a mistake. So always write this substitution in. Don't just go at 0, this stuff is just 0. Always write in your substitution for 0 so that you aren't going to make mistakes with trig and exponential type functions. Let me put that into our calculator, we're going to end up with 36 minus 0. And that ends up being equal to 6. So our average velocity over our journey is 6 meters per second. And that is how we work with our average velocity using integration. And that is what we need for now.